Good afternoon to everyone. I am M. Pravin Kumar Swero from TSWREIS Fine Arts Malkajgiri. Friends, daily we are around different forms of energies. One such form of energy is sound energy, and we are surrounded around different types of sounds. Friends, as I told that I am from Fine Arts School and I am a theatre art student and I am also very fond of music. Being a student of fine arts, I developed curiosity in music and I wanted to know how my friends are able to produce different tunes on the same musical instrument and how different musical instruments are sounding in a different way. I heard one of my friend is playing different tunes on guitar, and I heard another friend when he was playing violin. I wondered how one musical instrument can produce different tunes and why violin and guitar are sounding in a different way. To satisfy my inquisitiveness, I went to my friends and teachers and inquired about production of sound. During my study, I understood that there is physics behind production of sound by these musical instruments, which I am going to explain now in my presentation. So friends, today my topic is about physics behind musical instruments. I am repeating again, my topic is about physics behind musical instruments. Music is a movement of sound to reach the soul for the education of its virtue. It is a quotation said by a great philosopher named Plato. Friends, at the end of my presentation, we will be able to explain and define what is sound and will understand the key terms which helps us in understanding the topic, and will differentiate between music and noise, and also at the end of my presentation we will be able to learn the physics behind different musical instruments. Let us learn about sound. What is sound? Sound is a form of energy which causes sensation of hearing. Then how it is produced? How the sound is produced? Sound is produced by a vibrating body. Any body which is having to and fro motion is known as vibrating body. For example, when I am speaking to you, my vocal cords are vibrating, and when I place my fingers on my vocal cords are vibrating. Since my vocal cords are vibrating, the sound is produced. Now I didn't speak to you because my vocal cords are not vibrating, so the sound doesn't produced. Friends, for example, I took a tuning fork and a rubber hammer. When I hit this tuning fork to the rubber hammer, the prongs of the tuning fork start vibrating. But friends, can you hear? No. I can hear. When I hit this to rubber hammer and when I place on surface area, you can hear because surface area is increased, so the volume of the sound increases. Friends, sound needs a medium to travel. That medium can be like solids, liquids and gaseous. Sound travels more faster in solids than liquids than gaseous, but the sound doesn't travel in vacuum. Friends, before learning the physics behind different musical instruments, we need to learn few key terms which helps us in understanding the topic. Let us go through one by one. The first and foremost thing is wave. What is wave? Wave is a disturbance created in a medium. When a sound is produced by a vibrating body, it creates vibrations, and this vibrations creates disturbance in the medium, and this disturbance reaches our ears and causes sensation of hearing. And sound wave needs a medium to travel, and disturbance creates compressions and rarefactions, which is a longitudinal wave. Let us learn about longitudinal wave in our next slide. In longitudinal wave, the particles of the medium vibrate parallel to the direction of propagation of wave, and in longitudinal wave, compressions and rarefactions are formed. Let us learn about compressions and rarefactions. Compressions are the region where the particles are closer, are having high density, high pressure and high temperature, and whereas rarefactions are the region where the particles are far and having low density, low pressure and low temperature. Friends, if you look at the slide, here the particles which are closer are known as compressions, and here the particles which are far are known as rarefactions and denoted by R, and compressions are denoted by C. Friends, for example, in string instruments we will take guitar. When we plug the strings of guitar on the strings, transverse wave is formed. In transverse wave, the particles of the medium vibrate perpendicular to the direction of propagation of wave, and in transverse wave, crest and troughs are formed. Let us see about crest and trough. Crest is a point on a wave with a maximum value of upward displacement, and whereas trough is a point on a wave with a minimum value of downward displacement. Friends, if you look at the picture on the slide, the upward displacement is crest and the downward displacement is trough. Friends, and as we know that on the strings it is a transverse wave, and when disturbance comes in the air, it is a longitudinal wave, and the strings on the guitar are having two endpoints. So the wave, when we plug the strings of guitar, on the strings transverse wave is formed, and the transverse wave travels forward and hits the other end and again reflects back. The wave which travels is known as incident wave, and the wave which reflects back is known as reflected wave. Combination of two waves moving in opposite directions is known as stationary wave. Stationary wave is also known as standing wave. These waves have same frequency and same amplitude, and in stationary wave, nodes and antinodes are formed. Let us learn about nodes and antinodes in our next slide. Points along a stationary wave where the wave has minimum amplitude is known as node, and points along a stationary wave where the wave has maximum amplitude is known as antinode. Friends, if you just look at the picture on the slide, it is here red dotted and blue dotted points are antinodes, which is having maximum amplitude, and the black and these blacked dot points are nodes, which is having minimum amplitude. Friends, let us learn about wavelength in our graphical representation of wave in our next slide. If you just look at this graphical representation of wave, the distance between two successive compressions or rarefactions is called wavelength. If you see, and wavelength is represented by lambda, Lambda, lambda. It is a Greek letter. If you just look at the graphical representation, on the x-axis it is time, and on the y-axis it is displacement. Friends, here it is a compression and here it is also a compression. So the distance between these two successive compressions is known as wavelength, and this is one rarefaction, this is also one rarefaction. So the distance between these two successive rarefactions is known as wavelength. It is in the case of longitudinal wave, and if it is a transverse wave, this will be crest and this will be crest. So the distance between these two successive crests is known as wavelength, and if it is a crest, it will be a trough. So the distance between these two successive troughs is known as rarefaction, is known as wavelength. Friends, we need to learn about the main concept, that is about frequency. Let us learn about in detail about frequency in our next slide. Number of vibrations by a particle in the medium in 1 second is known as frequency. It means number of vibrations produced in 1 second is known as frequency, and the SI unit of frequency is Hertz, Hertz. Hertz. In short term, we will write it as Hz, and frequency is represented by nu. It is also a Greek letter. For example, I took a tuning fork and a rubber hammer. When I hit this tuning fork to the rubber hammer, the prongs of the tuning fork start vibrating. They are vibrating for 512 times in 1 second. It's given here. So the frequency of this tuning fork is 512 Hertz. For example, let us take another tuning fork. When I hit this tuning fork to the rubber hammer, the prongs of the tuning fork start vibrating. They are vibrating for 256 times in 1 second. So the frequency of this tuning fork is 256 Hertz. In the first tuning fork, it is vibrating for 512 times. So it is higher pitch. It means more number of vibrations are produced. So the pitch will be higher, and here less number of vibrations are produced. So the pitch that produced will be lower, it means low pitch. And friends, let us relate this with musical instruments. More frequency is equal to higher note, high pitch. It means if a string produces more number of vibrations in 1 second, the pitch will be higher. It means the note will be higher. And less frequency is equal to lower note, low pitch. It means if a string produces less number of vibrations in 1 second, the pitch that produced will be lower. It means low pitch, lower note. Friends, let us learn about the relation between amplitude and loudness in our next slide. Loudness is also known as intensity of sound, and loudness is directly proportional to the square of amplitude. It means that intensity is directly proportional to the square of amplitude. That is, if the amplitude is more, the volume of the sound will be high. If you just look at this picture, it is amplitude and this amplitude is more. So the volume of the sound will be higher, and less amplitude is equal to low sound. It means that if the amplitude is less, here if you observe, this is amplitude which is less, so the sound that produced will be lower. Friends, do we like to hear all the sounds produced around us? No, I can't like to hear some of sounds, but I can like to hear some of sounds which are produced around us, like music, the sound which creates pleasant sensation on ears and having regular vibrations is known as music. For example, the sound which is produced by guitar, piano, tabla, veena, etc. And whereas the sound which creates unpleasant sensation on ears is known as noise, and having irregular vibrations is known as noise. For example, the sound which we make in our classroom, of course, in the absence of teacher. Friends, let us see the physics behind different musical instruments like string instruments, percussion instruments and wind instruments. Let us see the physics behind string instruments. String instruments produce sound by plucking or bowing the strings, and strings can be plucked or bowed. Plucked in the case of guitar, veena, sitar and etc. And violin is bowed. And friends, the belly of the instrument acts as an amplifier which produces high sound, and guitar, violin, veena, sitar. These are some examples for string instruments. Let us see the physics behind different musical instruments. Friends, here I took a guitar, so I'll play different tunes, okay? Friends, here I played different tunes in different ways. So the different tunes which are produced on guitar is based on this formula, that is V is equal to nu lambda. I am repeating again, V is equal to nu lambda. Here V is velocity of wave and nu is frequency and lambda is wavelength. Friends, from this above formula, on subjecting frequency, that is nu, we get nu is equal to velocity by lambda, that is nothing but nu is equal to V by lambda. So from this above relation, that is nu is equal to V, we can say that frequency is directly proportional to velocity, and also from this relation we can say that frequency is inversely proportional to wavelength, that is nothing but nu is directly proportional to lambda. Let us see the first case, that is nu is directly proportional to V. It means that if the velocity increases, the frequency will also increases. If the velocity decreases, the frequency will also decrease. Let us relate this with musical instruments. It means to create higher pitch or higher tone, the frequency should be more. For more frequency, velocity should be more. For more velocity, tension of the string should be more, which can be done by tightening the strings with the help of tuning knobs. Friends, if you just observe here, when I pluck the string which is tighter, which is fixed tightly, the pitch that produced will be higher, and when I lose this string, if you observe, the pitch that produced will be low. You can see the difference between the first one and the second one. And friends, let us see with other strings. Here I am tightening the string. So when I plug the string, the pitch that produced will be higher. And this second string is of tighter. So when I plug the string, the pitch that produced will be higher. You can see the difference and note the difference. When I lose this string, the pitch that produced will be low. You can see the difference between the first one and the second one. And friends, for more tension, the string should be of less mass, that is thin string, which can be done by taking the strings of different thickness. If you just observe here, these three strings are of less mass, that is nothing but thin string, which can be done by taking the strings of different thickness. If you just observe, these three strings are of thinner size. So when I plug these three strings, the pitch that produced will be higher. And here these three strings are of thicker size. So when I plug these three strings, the pitch that produced will be lower. You can note the difference between the first one and the second one. And friends, there is another way to increase frequency, that is to create higher pitch or a higher tone. The wavelength should be less, as frequency is inversely proportional to wavelength. That is, the length of the string should be less for more frequency, which can be done by fingering. Friends, if you just observe, here the length of the string is more. So when I plug this string, the pitch that produced will be lower. Note the difference. And here the length of the string is less. So when I plug this string, the pitch that produced will be higher. So there is difference between the length of the string is larger and here the length of the string is of small size. So let us check with other strings. You can see the difference between the first one and the second one. And friends, if you just look at in the next slide, here it is a model of a string instrument. It is a belly of the instrument which acts as an amplifier, that creates the high sound. And here are strings of different thickness which produces different tunes. These three strings are of thinner and these three strings are of thicker. These three strings produce a high pitch and these three strings produce low pitch. And friends, these are the tuning knobs. Helps us to change the tension of the string. It means with tightening the string. If we tighten the string, the pitch that produced will be higher. And if we loosen the string, the pitch that produced will be lower. Here I am losing the string, so the pitch that produced will be lower. And fingers are used to change the wavelength. I am using my fingers to change the tunes. You can see the difference between these strings. And friends, here is a small musical scale of piano. Here if you just look at this slide, here less number of vibrations are produced. So the pitch that produced will be lower, it means low pitch. And here more number of vibrations are produced. So the pitch that produced will be higher, it means high pitch. Friends, let us see the physics behind percussion instruments. Here, when I am hitting on the membrane, the sound is produced. So, percussion instruments produce sound by hitting the tightly stretched membrane, either with hand or with hammer. And instruments are struck with hand. When I hit the membrane with my hand, the sound is produced. And when I hit the membrane with the hammer, the sound is produced. And friends, this is the belly of the instrument which acts as an amplifier, and these are the tuning knobs, helps to tight the membrane or loose the membrane. And friends, jazz, tabla, mridangam, these are some examples for percussion instruments. Percussion instruments are also known as drum instruments, and usually different tunes are not played on percussion instruments. Percussion instruments are tuned to a specific note. They are tuned by tightening or loosening the head of the drum. It means tightening or loosening the membrane. And friends, if we want higher pitch in percussion instruments, the drum should be of small size and the membrane should fix tighter. So when I hit on the membrane, the pitch, the produce will be higher because of the membrane is fixed tightly and the drum is of small size. And if we want low pitch in percussion instruments, the membrane should be fixed tighter, looser, and the drum should be of large size. And when I hit this drum, the pitch, the produce will be lower because of the membrane is fixed loose and the drum is of large size. You can see the difference between these two drums. Because here the high pitch is produced and here low pitch is produced. Friends, let us see the physics behind wind instruments. Instruments that are mostly made up of wood and metal and have a reed mouthpiece. This is a reed mouthpiece which is made up of wood, and this is a flute made up of wood, and trumpet is a instrument which is made up of metal, and the sound is produced by passing the air into the tube, and the length of the tube can be varied by fingering. If we want higher pitch in wind instruments, the tube length of the tube should be less. If you just see, so when I blow the air into the tube, here high pitch is produced because the length of the tube is less, and here low pitch is produced because the length of the tube is larger, so the pitch they produce will be lower. Friends, we spend hours together in listening to the music. Are we wasting our time or do we have any advantages? Of course, no doubt we have advantages of music in our practical life. Let us see some of them. As according to different surveys, music is beneficial for individuals of all ages, and it is music therapy. Music therapy is an evidence-based clinical use of musical interventions to improve clients' quality of life by improving their cognitive, motor, emotional, communicative, social, sensory and educational domains. Not only human beings, music is having its applications in plants and animal life. Let us see some examples. Cows produced more milk while listening to the music, and dogs in kennels might be less stressed while listening to the classical music. Elephants and birds reacts to the music as human beings reacts. That is nothing but they feel pleasant while listening to the music. And some researchers discovered that seeds that were exposed to music and later germinated produced leaves of greater sizes and had other improved characteristics, and it practically changed the plant's genetic chromosomes. At last, we have a small recap that what we have learned. We learned about sound. Sound is a form of energy which causes sensation of hearing and produced by vibrating body. Any body which is having to and fro motion is known as vibrating body. And we also learned the key terms which helped us in understanding the topic easily. Like we learned about types of waves like transverse wave, longitudinal wave and stationary wave. And we also learned about the main concept, that is about frequency. Number of vibrations produced in 1 second is known as frequency. And more frequency is equal to higher pitch, higher note. It means if a string produces more number of vibrations in 1 second, the pitch will be higher, and it means the note will be higher, and vice versa. And we also differentiated between music and noise. the sound which creates pleasant sensation on ears and having regular vibrations is known as music, and also the sound which creates unpleasant sensation on ears is known as noise and having irregular vibrations. And we also learned the physics behind different musical instruments like string instruments, percussion instruments and wind instruments. In string instruments, if you want higher pitch, the length of the string should be less. Here the length of the string is less, so the pitch that produced will be higher, and the length of the string is more. So when I pluck the string, the pitch that produced will be low, and also the mass of the string should be less, that is nothing but thinner string. Here these three strings are of thinner size, so produces high pitch, and these three strings are of higher mass, so it produces low pitch. And also the tension of the string should be more, which can be done by tightening the strings with the help of tuning knobs. Here if you just observe, here the string is fixed tightly, so when I pluck the string, the pitch that produced will be higher, and if I loosen the string, the pitch that produced will be lower. And also friends, in percussion instruments, if you want higher pitch, the membrane should be fixed tighter and the drum should be of small size, and if you want lower pitch, the membrane should fix looser and the size of the drum should be larger. If you see the difference, here high pitch is produced, here low pitch is produced. And in wind instruments, if you want higher pitch, the length of the tube should be less, and if you want low pitch, the length of the tube should be more. And at last, I thank to Telangana government and TSAT channel.